Hello guys, welcome back to the fourth episode in our Salicylic Acid Saga. Today we'll be attempting to make 5,2-hydroxyphenyl azo-salicylic acid. First, we weigh out 300 mg of 2-aminophenol. Since I have a cheap eBay scale, the measurements will be a bit off. Next, we pipette out 0.6 ml of concentrated hydrochloric acid and 0.6 ml of water. We add them both to the aminophenol. We need to cool down our aminophenol suspension below 3 degrees Celsius, so we set up an ice bath. We can see that all of it won't dissolve in the HCl water mix. Then we weigh out 230 mg of sodium nitrite. We put it in a second beaker and add 0.5 ml of water.
The DJ makes you feel the beat. You just can't stop to move your feet. We can get the party started, so let's go.
We mix it up to get the nitrite into solution. We dropwise slowly add the nitrite solution to the aminophenol. We can see nitrous acid forming, which gives the solution a blue color just for a split second. Everything got pretty frothy and we can see the formation of a red colored gas that is probably nitrogen dioxide, which would indicate the composition of our nitrous acid, but I have no idea why. Since the temperature is low enough, it shouldn't do that. After we finished the addition, the temperature is at about 3 degrees Celsius. We see that it has an off-white, slight yellow color. We keep it chilled down since the solution contains the diazonium salt, which is temperature sensitive. We weigh out 60 mg of sodium carbonate and add it to the diazonium salt. For the next step, we'll add 30 mg of sodium carbonate to 2 ml of water. We'll also need 50 mg of sodium hydroxide, which we again add to the same beaker, and 300 mg of salicylic acid. Luckily, I accidentally weigh out a bit more since this happened. We mix until everything dissolves. We change out the beakers and put the salicylic acid solution into the ice bath. The temperature control is still quite important, and we want to cool it down below 5 degrees Celsius. Two weeks of work and experimentation has led up to this moment. After we add the diazonium salt, we should immediately get a bright colored product. The suspense was killing me.
Oh,
And all for nothing. We literally got another off-white, creamy colored solid instead of a majestic red dye. Disappointed, I filtered it off and dried it. After weighing it, we got about 340 grams of a still slightly damp product, which would correspond to a 51% yield. Let's summarize. This step of the synthesis was flawed from the very beginning. The paper I was following used aniline instead of amoniphenol, and they used much larger quantities, approximately 60-fold more of each chemical. Also, if we were to use aniline instead of the amoniphenol, we would know which product it would form. The biggest problem occurs in step 3, where we made the diazonium salt. Theoretically, it could, and it probably does, react with itself to form these compounds. Yikes! So not only that the diazonium salt probably gets wasted, it also forms two products. Big yikes indeed. That could maybe explain the slight yellow color we got, since we could have formed an azo bridge in that step already. Also, that would explain the lack of color change from the last step. Well, I don't know if I would call this synthesis a success. I mean, it wasn't a total fail either, since we got something in the end, even though we don't know what. I'll try to run a couple of tests, like NMR and IR spectras, and report back. Thanks for watching and tune in next time.